Welcome to my vlog on cybersecurity and big data. My name is Lim. I'm a computer scientist, an educator, and a software engineer. In this episode, I want to show you how to do historical IoC search fast using Databricks. So what is historical IoC search about? Right? Whenever you hear about a new threat on the news or on the threat intel feeds, you automatically want to go grab all the IoCs associated with that threat and check if the organization is affected. Sometimes that threat activity can happen months before the news of the threat is released to the public, which means that by the time you get the news and the IOCs, you have to look back at maybe months or maybe even a year's worth of data just to check if your organization is all right. Now, scanning through all that data is not easy and can be slow. And there are some tricks you can bring to bear to this, right? And Databricks is fantastic for this, right? So you can actually build summary tables or indexes. These are actually smaller, highly aggregated tables that will help you narrow down the search before hitting the raw data. I'm going to build on all the concepts and techniques that we have covered in the previous 2 episodes. So let's jump right in. I have loaded a much bigger data set, and I provided you with the notebook to actually do that. You can take a look. I'm not going to go through this. And let's take a quick look at the data. It has about 2.1 million rows. And if you take a peek at the data, it's fairly standard Zeek schemas. No surprises here, right? And I'm just calling it HTTP big just to distinguish it from the previous smaller HTTP table that I was using. Now, first step is to design and test out the summarizing scheme. And you have to do this for each protocol type. And so I'm doing this for HTTP. And basically, I would test out what would make sense for an analyst to look at in the summary tables. And in this case, really, I'm most concerned about the source destination IP addresses, the HTTP method, the status, and then possibly the user agent string. All right. And you may or may not want to include the user agent string. I try including URI because URI is actually nice to have, but then it introduces too much uniqueness. So the cardinality is too high. So I settled on this set, right? And I tested it out. It looks reasonable. And if I run it, if I run the count, it can shrink the data down to about 15,000 rows. So 2.1 million rows to 15,000 rows, pretty good, pretty good. So let's go with this. But we're not quite done yet, because what we really want is not just summarization of the data itself, but we want to pull out the observables that we extracted in episode 1, right? All the IPv4 or the FQDNs that are important for me to look at to match against IOCs. Right? So I want to actually pull those out and then use those to make a summary index structure, right? So of course, in production, I'll exclude a whole bunch of stuff like private IPs and popular like www.google.com. You don't want to index those, and you might want to also index hashes as well. But for this tutorial, we'll make it very simple. We just work with HTTP data and IPv4 observables. So I would take the extraction logic from episode 1, which is essentially this block here, and slap it right in here, right? Only slight changes I had to handle where the case by referrer is now, just for this this particular data set. But this is a good practice anyway. So with this, I tested this and I look at the resulting data. And it looks pretty reasonable. This is your time bucket. This is your observable value, source destination IP. The info gets slapped into a semi-structured string. And I do that because I want to make the schema extensible to handle the other L7 protocol types as well. Count, first seen and last seen timestamp. And this is pretty much all you need. All right. We are now actually ready to create a DLT job. Maybe let's quickly talk about how big should your time buckets be. I use 1 hour time buckets. You could use 1 day, you could use 3 hours, 6 hours. Depends, up to you. It's a trade-off between cost and analyst convenience. right? Because the bigger your buckets, the less time resolution you have in the summary tables. And then there's more likelihood that your analyst will need to zoom into the raw tables and will not be able to just rely on what's in the summary tables. So let's take that query and create the DLT job for it. So you create a SQL notebook, and I just slap on create streaming live table and partition by. The partitioning helps give more query performance. And there's other performance techniques that we can cover in the future episode. I slap on the streaming function around the keyword around the table, and that's pretty much it. And using what we showed you last time, you can create the Delta Live table. I've redone it here. I'm not going to show it again, and I've actually executed this as well. So let's see how we would use this. So I've executed that. It's created the summary all table. Let's see how we would use it. I would actually create a view to hide some of the complexity from the threat hunters, right? So I created a view. I further aggregated on time bucket, observable value, source destination IP, and I array agged the info into a details array. Put in HTTP, and then in production, you would sort of union this with all the other log types like DNS, SSH, Kerberos. Now we're actually ready to actually use this summary table to look for evil. So you query the view to look for evil, you typically supply a time filter and the observable value, and this will be where you'll plug in your IOCs, right? You could also do a ops value in a list of IOCs. That's totally possible. And I've executed this, and this is, in fact, this is so fast that I'm willing to kind of execute it online, and it just kind of came back in, less than a second. Right, and this is what it looks like, and you would kind of look through the results and see if there's anything suspicious. And suppose the second row is suspicious, and in fact, most times you will make a determination just by the data here, and you can see, oh, the get is it's a get, and then the status was 200 or was 400, so not to worry, the get didn't succeed, for example. But say the get succeeded and say, hey, this looks suspicious. I want to take a look at the raw data. I'll take the first seen, last seen timestamp, the source destination and IP address, and I'll slap it into another query on the source table. And you know which source table to go to because you stored the log type here. Right, so you slap it into the source table and you will query that. Now, this actually will take a few seconds because it's actually a huge, much bigger data set, right? And then you will bring back the raw data and you can inspect the raw data to your heart's content. And this is pretty much how you would speed up historical IOC search. And in the next episode, I'll be able to then talk about how do you handle IOC updates. I really needed the content in this episode. So that's all. I'll see you next time.